Okay, so today's topic is refraction formula and lens maker formula. Like, how will we derive these formulas and how to use them? Okay, so suppose we have this separation like this, and suppose on this side the refractive index is n1, and on this side the refractive index is n2, and this is the center of this separation of both the mediums. And suppose this is center of this curvature, and suppose radius of curvature is r. So if this point is suppose a, then AC will be equal to r. Now suppose an object is here and the light is traveling from medium n1 to medium n2. So first light is in medium n1, then light will go to medium n2. So what will happen? You can see it like here. Suppose this is incident light, and if I draw normal at this point, suppose I draw normal at this point. So normal at any point on the circle will passes through center of curvature. So this will be your angle of incidence I, and assume that N2 is greater than N1. So the medium on this side will be denser and the medium in which object is rarer. So the light will bend towards the normal. Suppose the light will go like this, and suppose the image is formed here. And suppose this is angle of refraction R. Okay, now let's drop a perpendicular from this point. And suppose this distance is very small. So this point will also be A. And suppose this point is O, this point is C, this point is I. Now you can see that at O, we have our object. So OA will be minus U. At C, there is center. So AC will be radius of curvature, that will be plus R. And at I, image is formed. So AC will be plus V. Because if we follow sign convention, then any distance measured in the direction of light will be positive. Any distance measured backward will be negative. Okay, suppose this angle is alpha. Suppose this angle is beta. And this angle is gamma. And remember, in this derivation, we have assumed that rays are paraxial in nature. Paraxial means they are traveling very close to the principal axis. So all angles are very small. So in this case, all the angles that we are viewing here are very small. And if you don't know, then if angles are small, then sine theta is assumed to be equal to theta, and tan theta is also assumed to be equal to theta. Now let us derive the relation between U, V and R and both the refractive index. Now how will we do it? Okay, so if you'll see that in triangle, suppose this point is P. So in triangle POC, I will be equal to alpha plus beta, because exterior angle is equal to sum of opposite interior angle. So if you'll see that tan I will be equal to tan alpha plus tan beta. The reason for writing this is that if angles are small, then sine theta can be returned equal to theta, and tan theta can also be written equal to theta, and theta can also be written to be tan theta. So I can be written to be tan I, and alpha will be tan alpha, beta will be tan alpha. So if you'll see, so putting the value of tan alpha and tan beta here, so tan I and I will be same. So tan alpha will be perpendicular is PA, base is OA, and tan beta will be perpendicular is PA, base is AC. Tan beta is perpendicular upon base, tan alpha will be perpendicular is PA, base is OA. Similarly, in triangle, if you'll see in triangle PCI, if you'll see the exterior angle is beta. So beta will be R plus gamma. So R can be written to be equal to beta minus gamma, but angles are very small. So beta will be tan beta, gamma will be tan gamma. So tan beta can be written to be again equal to PA upon AC, and gamma will be written to be equal to PA upon AI. So this is how we have written all the equations. Now, if you'll see that at the point of refraction, we can use Snell's law. So if I'll put Snell's law at point P. Suppose at point P, if I'll put Snell's law, so on this side, the medium is N1, and on that side, the medium is N2. So if I'll put Snell's law here, then what you will see is that Snell's law says that N1 sine I equal to N2 sine R. But if angles are very small, then we can write sine I to be equal to I, sine R to be equal to R. So we have N1 I equal to N2 R. And from our last equations, we know that I is equal to PA upon OA plus PA upon AC. So I will be PA upon OA plus PA upon AC equal to N2. And what is the value of R? That is PA upon AC minus PA upon AI. That is PA upon AC minus PA upon AI. That is PA upon AC minus PA upon AI. So if we'll see the PA all will cancel out. Now if we'll put the value, if you remember, OA was minus U, AC was plus R, and AI was plus 3. If you put all the values, you will get this equation, that is N2 by V minus N1 by U equal to N2 minus N1 upon R. So this is your refraction formula. N2, this is the medium in which light is going. N1 in the medium from which light is coming. And V is where image is formed, U is where object is there, R is radius of curvature. Please remember, if your curvature is like this, suppose light is traveling like this, then R will be positive. And if your curvature is like this, suppose light is traveling like this, then R will be taken to be negative. Because in this case, the center will be here, so it will be positive only. But in this case, the center will be backward, so it will be taken as negative. So R will be taken as negative. So this is your refraction formula. It is very important formula. The reason of this formula's importance is that many numerical depend on this formula. Okay, so let us first do some questions related to this formula. Suppose we have an object here at 20 centimeter from this point. Suppose refractive index is 2 here and 4 here, and radius of curvature is 20 centimeter. So my question is, where will the image be formed? So if we'll put the refraction formula, that is N2 by V minus N1 by U equal to N2 minus N1 by R. So N2 is basically 4. We have to calculate. N1 is 2. U is minus 20 because the object is on backward side. N2 is 4. N1 is U, and R will be plus 20 because the curvature is like this. So it will be like this. So for this equation, you can calculate V. So this is how you have to use the refraction formula. Okay.